Red, white, and blue.
All right, today we're going to talk about rules related to perpendicular lines. Remember, this is your symbol for perpendicular, the upside down T. Rules related to perpendicular lines. All right, we're going to start off with the shortest segment from a point to a line is perpendicular to the line. All right, if you've got a line and you've got a point that's not on the line, and you're referenced to or you're asked about the distance, let's call this AB or AC right here. The distance from point P to AC. To find the distance from a point to a line, it's going to be the length of a segment perpendicular to the line. All right? Always. This has to be 90 degrees. If you were trying to find the distance from point P to line AC, you would not measure that blue segment, would you? No. Okay? And if you were trying to find the distance from P to AC, you would not measure this red segment either, would you? Okay? So when you're trying to find the distance from a point to a line, you measure or you find the distance of a segment that's perpendicular to the line that goes through the point. If you're asked to name the segment, or I'm sorry, name the shortest, you can insert shortest in there. Name the shortest segment from P to line AC. What would the shortest segment from P to AC be equal to? B. What would that be? Segment PD, wouldn't it? All right. D's right here.
Oh, I thought that was P.
P is up here. Name the segment. Name the shortest segment from P to AC. It would be this segment PD, the black segment. If that segment, if you were told that that segment is 5 units long, and you were told that PA was x plus 3 units long, and you were asked to write an inequality, write and solve an inequality for x. remember, when you're writing an inequality, you're going to use less than or greater than symbols. Less than or equal to, or greater than or equal to. So in this case, write and solve an inequality for x. If x plus 3 represents the blue segment and 5 represents the black segment, isn't the 5 going to be less than the x plus 3? Okay? So 5 is going to be less than x plus 3. So there's writing the inequality, and to solve it, you would subtract 3 from each side. And 2 is less than x. And another way of writing 2 is less than x, you could also say x is greater than 2. Both of those are true. Yes?
Why is 5 less than x plus 3?
Because right above this triangle, you wrote that the shortest distance from a line, from a point to a line, is along a perpendicular segment.
Well, it has to be less if it's perpendicular, right? Because
Well, if you just look at it, the shortest segment from a point to a line is perpendicular to the line. Do you see this segment right here? Isn't it perpendicular to the line? Doesn't that make it the shortest segment from P to this line? So 5 is going to be shorter than x plus 3. So 5 is going to be less than x plus 3.
some is 5 would have been less than the red one too.
5 is going to be less than the red one as well. Try this, take a look at this diagram, and then we're going to do the same, or you're going to have the same instructions here. We're going to say, we'll call this point A, B, and C. We'll say that this is 90 degrees, that this segment is x minus 5, and AC is equal to 12. And if you're asked to name the segment, name the shortest segment from A to BC. What's the shortest segment from point A to line BC? Very good, AB. Write and solve an inequality for x. In this case, if AB, segment AB is the shortest segment from A to line BC, then isn't the x minus 5, is it going to be greater than or less than the 12? It's going to be less than. So your inequality is x minus 5 is less than 12.
Would you be wrong if you wrote a 12
No, it wouldn't be. You just have to make sure the inequality is pointing away from the 12. So if you add 5 to each side here, the 5's cancel out, and x is less than 17. Top of page 173. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So let's draw a picture of this, and it should make some more sense. If two intersecting lines form a linear pair of congruent angles, so watch. Here's two intersecting lines. Let me shorten this. Let's do this. Remember this mark right here? And this mark. Means those two angles are equal to each other, right? Is this a description of, or is this a diagram of two intersecting lines that form a linear pair of congruent angles?
Well, I don't think it is.
These two angles are a linear pair, aren't they? This angle on the left and this angle on the right, they're a linear pair. The two angles form a line. If two intersecting lines form a linear pair of congruent angles, they're congruent to each other, then the lines are perpendicular. All right, so these two lines intersect at 90 degrees. The only way that these two angles can be equal to each other and add up to 180 is if they're both 90, right? Okay? So if you're given this picture, you know that both of these angles are 90 degrees. In a plane, if a transversal is perpendicular to one of two parallel lines, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if we draw a picture of that in a plane, if a transversal is perpendicular to one of two parallel lines, so we need two parallel lines, and these lines are parallel when they get the red arrows on them. So L is parallel to M. If a transversal, so we need a transversal now, if a transversal is perpendicular to one of the two lines, so let's say that this transversal T is perpendicular to line L. If you're given this picture in a plane, transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if you're given this picture, here's what the rule states, that if T is perpendicular to L, and L is parallel to M, then T is also perpendicular to M. Okay? And then you're also going to want to write down that if two lines are perpendicular to the same line, then they are parallel. If two lines are perpendicular to the same line, then they are parallel. And don't write this down. You can just, just watch. Here's an example. If you get this picture, the question would be, is A parallel to B? It is, right? All right, isn't this a case where two lines are perpendicular to the same line? Okay. If two lines are perpendicular to the same line, then they're parallel to each other, so these two are parallel. All right, so is there anybody else that was confused on that first example I did, writing the inequality? Does anybody need to see another one of those? Or here, just look at the wall. Don't write this down. Just watch. If I gave you this picture, and told you that this was A, and this was B, and this is perpendicular, and this is 7, and x plus 10. If I asked you to,
We need to know this.
not really. Let's not use x. Let's use name the shortest segment in this diagram. AB is the shortest segment in that diagram, isn't it? All right, what if I asked you to write an inequality and solve for x? How does x plus 10 relate to the 7?
It's greater than 7.
The x plus 10 is longer than the 7, isn't it? This segment right here is longer than this segment. Because by rule, you know that a segment perpendicular to a line is the shortest segment. So x plus 10 is greater than 7. So if you subtract 10, then x would be greater than negative 3. Anything greater than negative 3 would make that true. What if you had to set up this inequality? 6x plus 5 is less than 9x minus 3. Do you guys remember how to solve with variables on both sides? We did that, right?
Yeah.
But we've been doing it with equal signs. Okay, so you're just going to deal with the inequality. What would you do first here? Somebody give me a...
Subtract 6x.
Okay, subtract 6x. So 5 would be less than, what's 9x minus 6x? 3x minus 3, and then
Add 3 to it.
add 3. So 8 would be less than 3x. Divide by 3, right? So 8/3 is less than x. Does everybody have a calculator on their desk? I want to show you something. Type 8/3 in your calculator, please. Yes.
I thought you divided or multiplied with the less than or greater than sign, it's like
Only when you multiply or divide by a negative. Alright? Just type 8/3 in your calculator. And then push second and the fraction button. Fraction button is left of 1. Did you see what it did? Did it convert it to 2 2/3? Okay. Does everybody see how to use that button? If you're given an improper fraction, or if you solve for a variable and you get an improper fraction, but on your test or quiz, none of your answers are improper fractions, you can convert it to a mixed number. All right, so push second fraction button again. And what does it do?
Converts it back to 8/3.
Converts it back to 8/3. Very good. I want you to look at this for a second. If this is 3y minus 2x, and this is 90, and these two are parallel, and this is 2x. All right, this is the type of practice you're going to get today, and you're going to be asked to solve for x and y. If this angle is 90 degrees, then what do you know about this angle? It's 90 degrees, isn't it? What do you know about this angle? 90. So what does 2x equal to?
90.
90. So can you solve for x? Okay.
By 2.
Right, you can solve for x, and then what is this angle equal to?
90.
Right here. It's 90 as well. So once you solve for x, can't you substitute it right here for the x? And set this expression equal to 90? So you would have 3y minus 2 times 45 equals 90, right? Does everybody see that? Okay. Then I want you to look at this picture. If this is 90, 2x plus y is right here, and 10x minus 4y. We're back to that double variable thing that you had to address last week. What are all of the angles equal to in this diagram? They're all 90 degrees. So is 2x plus y equal to 90 degrees? And isn't 10x minus 4y equal to 90 degrees? So don't you have a system of equations where, how could you solve for one of the variables here? Does anybody see what the first step would be?
Take out the y.
Multiply the top equation by -5, right? What else could you do? Could you multiply the top equation by 4?
Mm-hmm.
If you multiply the top equation by 4 times 4, you would get 8x plus 4y equals 360. And if you do nothing with the bottom equation, you're going to get 10x minus 4y equals 90. And then can't you add the two equations together? So you would get 18x equals 450. Does everybody see that? Understand that? I'm not going to do any more of it because it's in your assignment today. But don't these y's cancel each other out? And then you can solve for x. And then you can plug it back in one of the equations and solve for y, right?
Wait, so
Doesn't matter which one you plug it back into.
we can do it the other way. This is another way to do it, right?
This is, well, you could have multiplied the top equation by -5.
Well, no, I'm saying like, what was the question again? The question was
solve for x and y. Yeah.
So that means I could have did 2x plus y equals 90. Figured okay, I see it.
See, if you just solve for y, you're going to have a variable in your
Variable,
answer,
yeah, okay.
and it just becomes messy. So it goes back to when you see two variables, start thinking systems of equations again. All right. And we talked about it a little bit last week. So your assignment for today is going to be, it's going to start on page 175. Problems 1 through 3, 6 and 7, and then over on the next page 10 through 15. And please check headline for homework.